All right, guys, let's do another energy, conservation of energy problem. But this time I would like to involve work. So we have an example of having work done on our system. I have a situation here where I have an object, maybe a textbook, very heavy textbook, that is sitting on the ground, and a person has picked it up and put it on the table. We have gone from having no forms of energy, so we have no height, so there's no gravitational potential energy, and it's not moving, so there's no kinetic energy, to it having height at the top, so we've got gravitational potential energy, but again, it's still not moving. So we went from no energy in our system to having energy in our system. So we've got our object in our system, but our hand is out of the system, lifting up the object. And we're going to have energy flow into our system. We've gone from nothing to something. So we're going to have an arrow pointing in so we can remember that our hand did work on the system. Now we're going to write our qualitative energy equation. So on our final snapshot side, we have our gravitational potential energy because it's the only form of energy present. And on the other side, we don't have anything, so we're going to put work. Okay? Now let's plug in our formulas and do qualitative, make our qualitative energy equation quantitative. So formula for work is force times distance times cosine theta, and that's equal to mgh. Now, first things first, let's deal with that cosine theta. The force is in the same direction as our motion, so we can go ahead and cross that out. We don't have to think about angles at all. So now we just need to solve for force. That's the only thing we don't know. We know height, we know what gravity is, we know the mass, we know the distance of the traveled. Let's solve for that force. Let's do the algebra first. Bring our equation over here. So we've got force times distance equals mgh. Let's divide away the distance. And now we're just left with force. The distance traveled is equal to the height gained, so we can also just go ahead and cross that out. So the force is going to be equal to mg in this case. We know that our mass is 0.5 kilograms, and we know that gravity is 9.81 meters per second squared. Let's just plug that into a calculator and figure out what our final answer is. We just need to do 0.5 times 9.81, and that is going to be 4.9 newtons. Even though this was a really simple problem, it's the same process every time we have work in our problem. So I hope this is a really helpful example for you.